Hello students, here I'm going to start discussing of all the solutions from practice set 1 of algebra and applications. Here is the first question. If the ratio of a plus b and a minus b is 5:3, then what will be the value of the ratio a square plus b square and a square minus b square? Let's start with the solution first. That is, let's write the given expression 5/3, and then in the next step we will do the cross multiplication there. 5a minus 5b. Also, now we would like to keep the like terms in the same side. So 3a, let's bring 5a to the left side, minus 5a, and minus 5b minus 3b. So it becomes minus 2a equals to minus 8b. Now we can understand that both side minus will got cancelled, and a divided by 2, 4. So a equals to 4b. And we are going to use this result in the required in the given expression to find the desired value, that is a square plus b square by a square minus b square. Okay, so here let's put the value of a in terms of b. 4b whole square plus b square, 4b whole square minus b square. It will give us 16b square plus b square, 16b square minus b square. Now it becomes 17b square by 15b square. We can say that both b square will got cancelled and we will be left with only 17 by 15. So the value of the ratio is 17:15. Option A is the correct one. Now let's move towards the next sum, which is if x equals to √3 plus √2, then the value of x plus 1 by x is, okay, so let's start with the solution. First write x equals to √3 plus √2, right? Now, what will you do? We are going to find the value of 1 by x. In order to do that, we are given with 1 by √3 plus √2, correct? Since √3 plus √2 is an irrational expression, we would like to rationalize it by multiplying the conjugate of this rational number. That is √3 minus √2. We would multiply both numerator and denominator by √3 minus √2. So √3 plus √2, √3 minus √2. So it becomes √3 minus √2 by, look here, it's in the form of a plus b multiplied by a minus b, and from the algebraic formula we know the value of this a square minus b square. We are going to use that here, √3 whole square minus √2 whole square. That means √3 minus √2, 3 minus 2, it becomes √3 minus √2. That's the value of 1 by x. Now we are going to use separately both the values in the expression of x plus 1 by x, that is √3 plus √2 plus √3 minus √2. As you can see, √2 plus √2 and minus √2 both got cancelled, and the result is 2 √3. So here option B is the correct one. Okay. We have arrived to the third question. If x plus y equals to 2z, then the value of x by x minus z plus z by y minus z is, okay, so let's start with the solution. Look, we are given with the expression of x plus y equals to 2z, correct? Now we will use this in the coming steps. Start with the expression first. y minus z, right? Now in the next step, we will do the LCM. So x minus z multiplied by y minus z, okay? And y minus z plus z multiplied by x minus z. Next, in the next step, let's drop the brackets and do the multiplication over here. So it becomes xy minus xz minus yz minus plus z square. And in the numerator, we will get xy minus xz plus xz minus z square, correct? Now look here, in the numerator both minus xz and plus xz will got cancelled, so xy minus z square. And in the denominator we can see that we can take common minus z from both the second term and the third term, and it would become x plus y plus z square. Okay, so now we can see that we got the expression of x plus y. So we can use that given result in this fraction. So xy minus z square, xy minus z multiplied by 2z plus z square. So here xy minus z square, xy minus 2z square plus z square. Okay, let's do the next step. Minus 2z square plus 2z square would give us minus z square in the denominator, and same we have in the numerator as well. Means both got cancelled and would get the value 1. So here option A is the correct answer. Okay, let's move towards the next sum here. So we can see there are some statements are given. Let's read out them. Consider the following of all real numbers t, u, and v. 1. If t square plus u square plus v square equals to tu plus uv plus vt, then t equals to u equals to v. Okay, and the next statement states that if t plus u plus v equals to 0, then t cube plus u cube equals to v cube equals to t e 3t uv. And the third is if t plus u equals to v, then t cube equals to u cube equals to v cube plus 3t uv equals to 0. Which of the above statements or statement is or are correct? Okay, so first we will start our examine with the first statement. Let's write here. Let's write here. It's given t square plus u square plus v square equals to tu plus uv plus vt, correct? Now let's take the expression which is given in the right side to the left side. So it becomes v square plus u square minus tu minus uv minus vt equals to 0. Now we can take common from some terms like t from t square and tu. So it becomes t multiplied by t minus u as well, plus next we can write plus v minus t, and next plus u minus v equals to 0. Now this statements holds true, or this is only possible if t equals to u equals to v. So we can write this is possible only if t equals to u equals to v. Like if I make them equal, you can see if I make them equal, like t equals to u equals to v, I can write like t for each u and v. So after taking common t from the three expressions, three terms, it will become t minus u plus v minus t plus u minus v. Now look here, you got cancelled v t t, so t multiplied by 0 equals to 0. So look, it only holds true if t equals to u equals to v. That means statement 1 uh, statement 1 is true. Now we are going to check statement 2 and statement 3 as well. Like, so here for the statement true, let's write it like t plus u plus v equals to 0. It's given. And we are required to prove that t cube equals to v cube equals to u cube equals to 3t uv, right? Now, since these all are t, u, v, all are real numbers, we can take it as let t equals to 1, u equals to 2, and v equals to minus 3, right? Now let's put all the values and check. 1 not equals to minus 27, obviously not equals to 8, and not equals to minus 3 3s are 9, 18, correct? So that means not true. Statement 2 is not correct. Not correct. We can see not correct. Now let's check statement 3. That is, it's given like if t plus u equals to v, then we need to check whether the statement t cube equals to u cube equals to v cube plus 3t u v equals to 0 or not. We need to check this, correct? So again, we will assume let t equals to 1, u equals to 2, and v equals to 3. This will, satisfy this relation. So here, let's put all the values. So 1 equals to 8, 1 equals to 27 plus 3 3s are 9, 18, and so these are not equal, correct? So again, this statement is not, doesn't hold true, so not correct. Not correct. So we have come to the conclusion that only one only, the first statement is correct only here. Okay. Here is our fifth question. If x square plus y square minus 4x minus 4y plus 8 equals to 0, then the value of x minus y is? A very good question, I must say. Let's start with the solution. First, write down the given expression. Plus 8 equals to 0. Right. Next, what we can do, we will group them, we will organize them in such a way that we can extract a formula from it. Like if I group x square minus 4x, and this 8 can be written as 4 plus 4. So 1 4 will be associated with the first grouping, and the second group we can make y square minus 4y plus 4 equals to 0, correct? So here you can see it's look like a formula of a minus b whole square. We already know the result, a square minus 2ab plus b square. So here a is x and b is 2, because we know 2 square give us the value 4. So x minus 2 whole square plus y minus 2 whole square equals to 0, correct? We already know that the sum of two squares, or sum of the square of two terms is equals to 0, then we can say that either of the term is equals to 0. That means either x minus 2 equals to 0, so x equals to 2, or we can say y minus 2 equals to 0, that means y equals to 2. Now we will put the values of x and y both in the given expression, in the expression which we are required to get the answer, that is x minus y. 2 minus 2 equals to 0. So here we can see option C is the correct answer. I hope it got clear to you. Now let's move towards the next 6. If 5a plus 3a equals to 5, then the value of 9a square plus 1 by 25a square is. Okay, so let's start with the given expression first, that is 5a plus 1 by 3a equals to 5. Correct. Now, what we can do in order to get the expression like 9a square plus 1 by 25a square, I would like to multiply both sides with 3 by 5. So 3 by 5, 5a plus 1 by 3a, and 5 multiplied by 3 by 5. Now in a bracket, let me write the operation that I have done here. Multiplying both sides with 3 by 5. Correct. Now let's do the multiplication. It becomes 3a plus 1 by 5a equals to 3. In the next step, we would like to do the square of the both sides. So squaring both sides, squaring both sides, 3a plus 1 by 5a whole square equals to 3 square. I hope you can remember the formula of a plus b whole square. But again, I would like to write it for you. A square plus 2ab plus b square. Okay. So in the next line, it becomes 9a square plus 1 by 25a square plus 2 multiplied by 3a multiplied by 1 by 5 equals to 9. So 9a square plus 1 by 25a square plus both a got cancelled and 6 by 5 equals to 9. Look here, we have already got the expression 9a square plus 1 by 25a square in our calculation. Just we would like to bring this 6 by 5 to the opposite side, to the other side, and let's do the calculation of the subtraction of these two numbers. It becomes 45 minus 6 means 39 by 5. So it means option D is the correct answer. Okay, so here let's move towards the next sum. Question number 7 states that if 0.764y equals to 1.236x, then what is the value of y minus x by y plus x? So let's start with the solution. So here, let me write the given information first. 1.236x. Okay. So here we can write x by y as 0.764 by 1.236. Correct. Now look, here we are given y minus x by y plus x. So first I would like to write the reciprocal of this, which is y by x, and 0.1.236 by 0.764. Okay, now what can I do? Look at the expression attentively. It's y minus x by y plus x. So if I do the operation of componendo and dividendo, like componendo and dividendo on the both sides, we will get y plus 6 by y minus x. That means 1.236 plus 0.764. 1.236 minus 0.764, right? Now let's do the calculation over here. It becomes 2. So you got the value in the numerator as 2 and in the denominator 0.472. Y plus 6 by y minus 6, correct? And look here, again would like to find the reciprocal because we are required to find the value of y minus 6 by y plus 6. So y minus 6 by y plus 6, 0.472 by 2, and that would be in result 0.236. So here is the final answer, that is 0.236, correct? Now let's move towards the question number 8. So here is our question number 8. If A equals to 34, B and C equals to 33, then the value of AQ plus BQ plus CQ minus 3ABC is, there are 4 options given. Let's start with the solution steps. First, write down the expression that required to find the value. So here already given A equals to 34, B equals to 33, and C equals to 33 as well. Put all those values, 34 whole cube plus 33 whole cube plus 33 whole cube minus 3 multiplied by 34, 33 and 33. 34 whole cube would give us the value of 39304 plus 35937 and another 35937 minus 111078. Okay, so here in the next line we can get 8 minus 078. So it would result in 100. That means the correct option is option D, that is 100. Okay, now let's move towards the question number 9. If m to the power 4 plus 1 by m to the power 4 is 119, then find the value of m minus 1 by m. Okay, so m to the power 4 plus 1 by m to the power 4 equals to 119. To solve this sum, we need to know some important algebraic formulas. That is, first let me write e square plus b square, right? So it would be result in a plus b whole square minus 2ab, or a minus b whole square plus 2ab. Okay, now which one we are going to use in this sum? First, we will use the first one. We can write it as m square whole square plus 1 by m square whole square equals to 119. So that means here A is m square and b is 1 by m square, correct? So m square plus 1 by m square whole square minus 1 by m square equals to 119. In the next line, we can write m square plus 1 by m square whole square both m square got cancelled, and if I bring that -2 in the opposite other side, plus 2, it becomes 121. Let's square root both the side. So m square plus 1 by m square root under 121, that would result in 11, correct? Again, we can see it's in the form of a square plus b square, but this time we are going to use the result, the second result over here. That means m minus 1 by m whole square plus 2 multiplied by m multiplied by 1 by m equals to 11, correct? Why? Because we are required to find the value of the expression m minus 1 by m. Okay, so m minus 1 by m whole square, 11 minus 2, 9. Again, square root both sides, plus minus root 9. That would give in, that would result in plus minus 3. So here option A is the correct one. Okay. Let's move towards the next question. Number 10. One of the factors of the expression 4 root 3 x square plus 5x minus 2 root 3 is, there are 4 options given, and we need to find the factors. One of them will be matched with any of these 4 options, correct? So in order to find the fraction, we need to factorization. We need to do the factorization of this polynomial, and there are many more ways to do that, but we will do that by middle term method. Okay, so here to do the middle term, look at the constant term and the coefficient of x square. We will find the product of this two. It would give us the value 24. Now we're going to find such pair of the factors of 24, so that the if we subtract one number from the other, we will get 5. Why do we need to subtract? Because here before the constant part, minus sign is given, correct? Now if I say like 8, 3, these are the two factors also, or 4, 6, these are the two factors. Now see which pair is give us the subtraction value 5, that is 8 and 3. Like if I do 8 minus 3, I will get 5. So this expression can be written in such a way that plus 8x minus 3x minus 2 root 3. Look, it I just balanced it in such a way, but the value or the meaning is same as before. Now let's take the common from first and the second term, 4x root 3x plus 2, and the from third and the fourth term, I can take common minus root 3, that would result in root 3x plus 2. So here root 3x plus 2 and 4x minus root 3. Okay, so the factors, one of the factor of this expression is, we can say 4x minus 3. That means option C is the correct one, right? Let's start solving question number 11. A plus b whole cube is equal to, there are 4 options given. So let's start with the solution first. A plus b whole cube. We already know the formula of in important algebraic expressions. Let's expand this. A cube plus 3a square b plus 3ab square plus b cube, correct? Now I will balance it. I will organize it some way so that they matched with any of these options. Okay, so here a cube plus b cube plus, if I take 3ab common from second and the third term, I would get a 3ab a plus b. Now look here, option 3 is the correct answer, right? So we got here. Next, our next question is question number 12. if a plus b plus c equals to 8, then the value of, there is an expression given, we are required to find the value of that expression. Okay, so let's start with the solution then. Look, this expression, okay, let me write the whole expression first. A minus 4 whole cube plus b minus 3 whole cube plus c minus 1 whole cube minus 3 a minus 4 b minus 3 and c minus 1. Correct. Now I can assume them like a minus 4 as x, b minus 3 as y, and c minus 1 as z. Correct. Now adding this x, y, and z, I will get x plus y plus z as a minus 4 plus b minus 3 plus c minus 1. That means a plus b plus c minus 8. Right? Now we are already given with the information that a plus b plus c equals to 8. This is already given. So I will put the value of a plus b plus c here. 8 minus 8 will give us the result 0. That means x plus y plus z equals to 0. Correct? So we have also we know we have an identity that if x plus y plus z equals to 0, then we can write from the identity as well x cube plus y cube plus z cube minus 3xyz equals to 0. Correct? Now let's put all the values of xyz over here, because we have assumed the value x and y and z in the play instead of a minus 4, b minus 3 and c minus 1. Correct? So here a minus 4 whole cube plus b minus 3 whole cube plus c minus 1 whole cube minus 3a minus 4 b minus 3 c minus 1 equals to 0. So we have got our final answer, which is 0. Option D is the correct one, right? Let's check the next question. Question number 13 states that if n equals to 7 plus 4 root 3, then find the value of root n plus 1 by root n. Well, it's a very good question. Let's start with the solution then. So n equals to 7 plus 4 root 3. So it's a irrational number. It's a mix of whole number part and irrational number part. Correct? So first what we will do, I will try to find the value of 1 by n. That means 1 by 7 plus 4 root 3. Correct? So here, since it is an irrational expression, so I need to rationalize it first. So in order to rationalize it, I would multiply both the numerator and the denominator with the conjugate of 7 plus 4 root 3. That means 7 minus 4 root 3. Okay, so 7 plus 4 root 3, 7 minus 4 root 3, and we have got it in the form of a plus b and a minus b. So from the identity we can write it as a square minus b square. Correct? So here 7 whole square minus 4 root 3 whole square and 7 minus 4 by 3. So let's calculate. 49 4 48, 7 minus 4 root 3, that means the value is 7 minus 4 root 3. Correct? Now since we are asked to find the value of root n plus 1 by root n, let's first try to find the value of root n plus 1 by root n whole square. Okay, so from the a plus b whole square identity I can write in plus means root n whole square plus 1 by root n whole square plus 2ab. Okay, so both root n will got cancel and we are only left with n plus 1 by n. And here we already know the value of n and 1 by n. Let's put the value separately over here, and it give us 14. Correct? 14 plus 2 means 16. So let's do the square root in the next line. Root 10 plus 1 by root 10, root under 16, that means 4. So here plus 4 means option B is the correct answer, right? Now after that, let's move towards the next question, question number 14. If the roots of the equation q square plus q plus 1 equals to 0 are in the ratio of j is to k, then which of the following relations holds true? Okay, that's a pretty good question, and to solve this, we need to recapitulate the relation of the roots and the coefficients, the relation between the roots of the equation and the coefficients of the equation. Let's first write it. Let's us assume that since the ratio of the roots are given in the form of j is to k, so I can write let the roots of the equation uh, are jx and kx, right? Here x equals to ratio constant. Okay, here x equals to ratio constant. Now first let me write the equation q square plus q plus 1 equals to 0. Okay, so we already know the relationship between the roots of the equation and the coefficients of the equation, and those are jx plus kx equals to minus b by a, minus b upon a. Wait, what is b here? Coefficient of q means 1, so minus 1, and what is a here? Coefficient of q square, that is again 1, so minus 1, and product of the roots equals to c by a. C means coefficient and a is the c is constant and a is the coefficient of q square, that means again 1, right? So from here I can write 1 by j plus k minus of, and here j multiplied by k x square 1. Now let's name it equation 1 and equation 2, correct? So taking the value of x from equation 1, I'm going to put it equation 2. That means it would become minus of j plus k whole square equals to 1. Okay, so jk, j plus k whole square, let's expand it, j square plus k square plus 2jk, or j square plus k square equals to minus jk, right? That means uh, let's take each term on the left side, so it becomes 0. Now I'd divide both the side with jk, that means g square by jk, k square by jk plus jk by jk equals to 0. Okay, it becomes j by k by j plus 1 equals to 0. So here which of the following relation holds true? You can see that option B exactly what we got in the result, j by k by j plus 1 equals to 0. So here also j by k by j plus 1 equals to 0. So here option B is the correct answer, right? Let's move towards the next question. Question number 15. If px if px plus qy equals to 6 and qx minus py equals to 2. So these are the two equations we are given. And also there is one more information: x square plus y square equals to 4. Then find the value of p square plus q square. Okay, how can we proceed with the solution? Look here, we are given with two linear equation, two simultaneous linear equation, correct? Now with the help of the elimination method, I can find the value of x and y from this two. Let's try to do that. So in order to solve by elimination method, what can I do? Like let's multiply equation number 1 by okay, by say p. Okay, and and equation 2 by q, and then add these two out. So p square x plus pqy equals to 6p, and also q square x minus pqy equals to 2q. Since from this two steps we can eliminate y, right? So it becomes, after taking x common, p square plus q square, 6p plus 2q. So x can be written as 6p plus 2q by p square plus q square, right? The same way we would try to eliminate the value x in order to find the value of y. Okay, so to do so we will multiply 1 by q and 2 by p, and then we will subtract each other. So pqx plus q square y equals to 6q, and pqx minus p square y equals to 2p. Now let's do the subtraction. I have changed the signs. Now after taking common y, p square plus q square equals to 6q minus 2p, correct? So y can be written as y equals to 6q minus 2p by p square plus q square. Okay, so we have already got the value of x and y in terms of p and q, right? Now we are already given with another relation between x and y, which is x square plus y square equals to 4. So I would like to put this value of x and y in that relation, in that equation. So x square plus y square equals to 4. Now let's put the value of x and y. 6p plus 2q by p square plus q square, 6q minus 2p by p square plus q square equals to 4, correct? So in the next step, since both are having the denominator same, which is p square plus q square, we can take it as common. So it becomes p square plus q square whole square, correct? So let's expand them according to the identity. It becomes 36p square plus 4q square plus 24pq plus 36q square plus 4p square minus 24pq equals to 0. Both 24pq will got cancelled, and it becomes 40p square plus 40q square, right? So it looks like complicated, which is not actually. It's pretty simple question. 40, after taking 40 common, p square plus q square by p square plus q square whole square equals to 4. Okay, since we can eliminate one p square q square, so it becomes 40 if we cross multiply with 4, this p square q square. And remember, we were asked to find the value of p square plus q square. So just bring this 4 down. Yes, 10. So we got the answer of p square plus q square, which is 10. Option D is the correct answer. Okay. Question number 16. If x plus 1 by x whole square equals to 3, then the value of x to the power 206 plus x to the power 200 plus x to the power 90 plus x to the power 84 plus x to the power 18 plus x to the power 12 plus x to the power 6 plus 1 is, well, that's a pretty large expression, but with the help of mathematics, we would simplify our calculation. And how can we do that? Let's see. X plus 1 by x whole square equals to 3. Okay, let's do the square root to the both side. It would give us x plus 1 by x equals to root 3. Right. Now, next, cubing both sides, we get cubing both sides we get what? X plus 1 by x whole cube root 3 whole cube, right? Let me make you remember the formula for a plus b whole cube again. That is a cube plus 3a square b plus 3ab square plus b cube. So x cube plus 1 by x cube. Well, there is one more formula, that is a cube plus b cube plus 3ab multiplied by a plus b. Yes, I'm going to use this particular one. Okay, so 3 here, x is, we are taking x as a and 1 by x as b. So 3 x plus 1 by x equals to 3 root 3, correct? Now x cube plus 1 by x cube. Look here, in terms, in place of x plus 1 by x, we can put this value root 3. So yes, 3 root 3 equals to 3 root 3. This both got cancelled. We got 0 here. X cube plus 1 by x cube equals to 0. That means we can write x to the power 6 plus 1 equals to 0. Right. Now let me make you remember that expression which we are required to find the value of. So let's write it first. X to the power 206 plus x to the power 200 plus x to the power 90 plus x to the power 84 x to the power 18 plus x to the power 12 plus x to the power 6 plus 1. Okay, now we can take common x to the power 200 from the first and the second term. It would make x to the power 6 plus 1. This way we would take x to the power 84 and x to the power 12 and 1 respectively, right? And both, all the x to the power 6 plus 1, this expression would give us value 0. That means it would make the whole expression 0. So here our answer is 0, and that matches with the option A, right? Now let's move towards the next sum. Let's start with question number 17. If T, U and V, these values are given in terms of G, H and I, where T, U, V are non-zeros, then what is G equal to? You can see there are 4 options given. I mean, total 5 options given. One is none of this. 4 different values are given that could be equals to G, right? Now, how can we proceed with this sum? Let me first write t equals to gh plus g plus h, u gi plus g plus I, v equals to hi plus h plus I. Okay. Now, this type of sum need to be better way, need to be done with the help of the options. Okay, so you have to check individually each of the options, putting all the values in each of the values in each of the expression, and which expression will give you the value g. So since I already know, so I'm already, started with that particular option, which is first option, option A. Let me show you. 2t uv by tv plus uv minus tu. Okay, I will put all the values of tuv in this expression. So it becomes 2 g square h square I square by g plus h, g plus I, h plus I, and whole divided by g h I, g plus I plus, okay, let me take one bracket here, multiplied by h plus I, g plus h minus g h plus I. Okay, denominator g plus h, g plus I, and h plus I. Okay, so let's check it again once more. G h I, g h I, and minus g hi. Yes. So now in the next step, what can I do? Look here, both the denominator will got cancelled. So also with this ghi, I will be left with ghi by, let's drop the brackets and do the multiplication. Gh plus hi plus gi plus hi minus gh minus gi. Right, now let's look here. So 2ghi by 2hi, yes, this results equals to g. So here option A is the correct one. Okay, that is, if root under 3x square minus 4x plus 34 plus root under 3x square minus 4x minus 11 equals to 9, then what is the value of expression root under 3x square minus 4x plus 34 minus root under 3x square minus 4x minus 11? Okay, so since it is a irrational expression, let's start with finding, let's make it reciprocal first. So 3x square minus 4x plus 34 plus root under 3x square minus 4x minus 11 equals to 1 by 9. Now we have to do the rationalization. So to do that, we would multiply both the numerator and the denominator with its conjugate. That means root 3x square minus 4x plus 34 of minus of root 3x square minus 4x minus 11, and in the denominator we would get root under minus 4x plus 34. Already it was there, 3x square minus 4x minus 11, and let's write the conjugate now. 3x square minus 4x plus 34. Okay, it should be minus so root under 3x square minus 4x minus 11, 1 by 9, correct? So it's in the form of a plus b, and a minus b. That means by the identity we can write a square minus b square, correct? So let's do it directly, and we would get 3x square minus 4x plus 34 minus of 3x square plus 4x plus 11, and already it's there, 3x square minus 4x plus 34 minus of 3x square minus 4x minus 11 equals to 1 by 9, correct? Now let's do the further calculation. Both got cancelled, only 45, right? So 45 minus 6, 4x minus 11, 1 by 9. So we can easily write the value of root under 3x square minus 4x plus 34 minus of 3x square minus 4x minus 11 equals to 5. So yes, that's the value of the expression, of the given expression. So yes, option C is the correct answer, right? Now let's move towards the next sum. Question number 19. If k by v plus w by l equals to 1 and l by w plus u by j equals to 1, then which of the following corresponds to the value of the expression j by u plus v by k? Okay, now let's start with the steps, solution steps. That is, we are given k by v plus w by l equals to 1, right? And look at the expression of the we are required to find the value. There is one term as v by k, correct? So is it possible for us to get that term from here? Let's try. K by v equals to 1 minus w by l. That means l minus w by l, right? Now let's do the reciprocal. It becomes v by k and l by l minus w. So we have already got the value of v by k in terms of l and w. Now let's write the another term, that is l by w, l by w and plus u by j equals to 1, right? And we are required to find the value of the expression j by u. Okay, so let's bring it to the other side. L by w and again w minus L by w, do the reciprocal. So j by u equals to w by w minus L. So we can name this equation 1 and this is 2. So from 1 and 2, or adding 1 and 2, on adding 1 and 2, we get j by u plus v by k equals to l by l minus Okay, yes, L minus W plus W by W minus L. So L by L minus W, we can take common minus 1 from the denominator of the second term, and it would make plus minus minus W by L minus W. So here both the denominator is same. Let's do the LCM. Minus W, so both will got cancel, and yes, here is the value of that expression is 1. So that means option B is the correct answer. Okay, now let's move towards the next sum, question number 20. When q cube plus 2q square plus 4q plus k is divided by q plus 1, the quotient is q square plus j cube plus 3 and the remainder is minus 3 plus 2k. What are the values of j and k respectively? Okay, so first, student, please do remember division algorithm. Division algorithm. What does it states? Let's say D is for dividend, right? And Q is the divisor and M is the quotient and R is the remainder, right? Let's say D is the dividend, Q divisor, M is the quotient and R is the remainder. So what will be the relationship in between them? That is D equals to QM plus R. Means if we add the remainder with the product of divisor and quotient, then we will get the value of dividend, right? So we are going to use this concept in this particular sum, that is we are already given with dividend, divisor, quotient and remainder, right? So let's write the relation between them. Q cube plus 2q square plus 4q plus k equals to q plus 1 product of the division and the quotient, so q square plus j q q plus 3 and that of plus of minus 3 plus 2k, right? So here let's proceed with the calculation. Q cube plus j q square plus 3q plus q square plus j cube plus 3 minus 3 plus 2k. Now we can take q square common, so j plus 1 and plus 3 minus 3 got cancelled. Also we can take q common from 3 plus j and plus 2k. Now q plus 2q square plus 4q plus k. So on comparing both the sides, comparing the coefficient of like terms on both sides, comparing the coefficient of like terms on both sides, we get, look here, the coefficient of j cube 1 1, right? Coefficient of q square 2, so we can write j plus 1 equals to 2. Next, coefficient of q 4, so we can write 3 plus j equals to 4 and k 2k equals to k. Now look, j equals to 1, also j equals to 1, that means the value of j is 1 and here the value of k equals to 0. So we got the value of j and k, that is 1 and 0. So here option A is the first one. Okay. Next, question number 21. If a plus b equals to 4 and ab equals to 7 by 4, what is the value of a square minus b square, right? So I hope you all can remember the identity a square minus b square. The result is a plus b and my product of a plus b and a minus b, correct? Now here we are already given the value of a plus b, so we need to find the value of a minus b, right? Now let me write all the given information first. A plus b 4 and ab 7 by 4. How can we find a minus b with the help of a plus b? Okay, there is a very important algebraic formula that a minus b can be written as root under a plus b whole square minus 4ab. Okay, so we have already know the value a plus b and ab. We would put all those value here. So a plus b 4 whole square minus 4 multiplied by 7 by 4. So 4 fours are 16 minus 7 means 9. Okay, so we can write a minus b. The value of a minus b is 3. Now we can easily put all this value to find the value of a square minus b square. 1 is 4 and 3. 1 is 4 and 3. So it's 12. Correct. Now one more thing. Look, root under 9. So we can write it as plus minus 3. Correct. So if we take the value plus 3, our results will be 12. But if we take the value minus 3, that means a square minus b square 4 multiplied by minus 3, it would give us the result minus 12. So here option C is the correct one, 12 and minus 12, right? Now let's move towards the next question. Question number 22, that is, what are the values of A for which 3m to the power 5 plus 9m to the power 4 minus 7m to the power cube minus 5m square minus 3gm plus 3g square is divisible by m minus 1. Okay, so let's name this polynomial, say fm. So let fm be, write the whole polynomial first, plus 9m to the power 4 minus 7m cube minus 5m square minus 3gm plus 3g square. Okay, so say that this polynomial is divisible by m minus 1, right? So this is divisible by, this is divisible by a minus 1, right students? Now please do remember factor theorem. What? Factor theorem. What does it say? Let's say there is a polynomial p of x, okay, and that p of x be divisible by x minus alpha, by the factor x minus alpha, then we can say that p of alpha would give us the value 0. This is what factor theorem states. So since here let's compare this m minus 1 with x minus alpha, we can say here the value of alpha is 1, right? So if I find m f of 1, we would get 0 because m minus 1 is one of the factor of this polynomial. So we are going to use this concept here. 3 plus 9 minus 7 minus 5 minus 3g plus 3g whole square equals to 0, or 3g square minus 3g equals to 3 plus 9 12 minus 12. Okay, this got cancelled, 0. So that means minus 3g g minus 1 equals to 0. Also, that is g of g minus 1 0. That means we can write either g equals to 0 or g minus 1 equals to 0. That would give us the value of g as 1. So the value of g is 0 or 1. That means here option D is the correct answer. Okay. Now let's move towards the next question. Question number 23. Let R, S and T be real numbers such that R plus T not equals to S. What is the quotient on dividing R cube minus S cube plus T cube plus 3RST by R minus S plus T? So are you thinking of doing the uh, procedure with the long division method? So no, we are not going to divide anything, but we are going to use a trick here. What is that? That is, we know, okay, let me first write it, t cube minus x cube plus t cube, sorry, it should be r cube here. So r cube plus 3r is t. Can you use any formula? Yes, do remember the formula of x cube plus y cube plus z cube minus 3xyz. What we can write from here, that is x plus y plus z multiplied by x square plus y square plus z square minus xy minus yz minus zx, right? So we are going to use this same identity over here. X we can assume, say, suppose x equals to t, y equals to minus s and z equals to r, correct? That means t whole cube plus of minus s whole cube. Let's start solving question number 23. Let R, S, T be real numbers such that R plus T not equals to S. What is the quotient on dividing R cube minus S cube plus T cube plus 3RST by R minus S plus T? Okay, let's start with the solution then. But before solving this sum, I would like to make you remember one of the most important identities, that is x cube plus y cube plus z cube minus 3xyz equals to x plus y plus z multiplied by x square plus y square plus z square minus 6y minus yz minus zx. Okay, we are going to use this result in the given sum. Now look how. First let me write the expression r cube minus s cube plus t cube plus 3rst. Okay, so this expression can be written as also r whole cube plus in the bracket of minus s whole cube plus t whole cube and minus 3r multiplied by minus this multiplied by t. Now look, I can compare r with x, minus s with y and t with z, so that I can use this first identity. So using that, I can write r minus s plus t multiplied by r square plus r square plus s square plus t square. So here minus plus r is minus plus is t minus rt. Okay, now look, r, we are dividing this expression by r minus s plus t, right? That means after on dividing this expression, we will be getting the quotient r square plus a square plus t square plus r is plus st minus rt. Look here, option B is the correct one. Okay, now let's move towards the next sum. So here 24, question number 24, if x equals to a minus b, y equals to b minus c, z equals to c minus a, then the numerical value of the algebraic expression x cube plus y cube plus z cube minus 3xyz will be. Okay, so again, let me write the identity first. So here x cube plus y cube plus z cube minus 3xyz. We can write the result as x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. Correct. Now we need to compare x as, we need to assume x as a minus b. Not only assume, this is already given. So y equals to b minus c, z equals to c minus a. Correct. Now adding this equations, adding this all three equations, adding this equations, we get that x plus y plus z equals to a plus b plus c minus of a plus b plus c. That means this two got cancelled and we will left with only 0. So yes, we can say if we put the value of x plus y plus z 0, it will make the whole result 0. That means x cube plus y cube plus z cube minus 3xyz equals to 0. So here option A is the correct one. Okay, now let's move towards the next sum. Assertion and reason. Okay, this is a different type of question where there is two statement given. Correct. Now look, in the assertion it's given 4m minus 5n equals to 1 and minus 8 by 5m plus 2n equals to minus 2 by 5 have infinite number of solutions. Okay, and in the reason statement it's given R1m plus S1n equals to T1 and R2m plus S2n equals to T2 have infinite number of solutions if R1 by R2 equals to S1 by S2 equals to T1 by T2. Correct. Now there are four options given that they're saying that both the statements are individually correct and the reason is the correct explanation, or both the statements are individually correct, but R is not the correct explanation, or any one of the statement is correct and the other one is false. So what is it? We need to prove that. We need to evaluate that. So let's start with the solution then. Look here that okay, so this is the correct state condition that this two simultaneous equations will have infinite number of solutions if R1 by the ratio of the coefficients with the constant is same. Right. Now let's check this condition with this equation. So we can see, first let me write the equation. 5n equals to 1 and minus 8 by 5m plus 2n equals to minus 2 by 5. Correct. Now 4 by uh, that is 4 by minus 8 by 5. Okay. Or I can write minus 5 by 2. Is this 2 equal? Let me check that. 5 by minus 2 from here I'm getting. So yes, minus 5 by 2, these two are equal. Correct. So that means we can say that these two equations have infinite number of solutions. Correct. We can individually prove that also. So here both the statements means both A and R are individually true. Okay. And R is the correct explanation of A. So here option A is the correct one. Okay. Now let's move towards the next sum. Question number 26. If a plus 1 by a plus 1 equals to 0, where a not equals to 0, then find the value of a to the power 4 minus a is. Okay, this is a good question. So we are given the expression a to the power 4 minus a. Now let's take a common from both the terms. It will make it a cube minus 1. Now in order to solve this, you need to know the identity of a cube minus b cube, right? So let me first write it here. The formula for a cube minus b cube, that would result in a minus b multiplied by a square plus ab plus b square. Okay. So here we consider as a and b consider as 1. So we can write a minus 1, a square plus a plus 1. Correct. Now we have a plus 1 by a plus 1 equals to 0. Now let's multiply both the sides with a. So it becomes a square plus 1 plus a equals to 0. Now we can put this value in this expression. That would make this expression as a to the power 4 minus a multiplied by a minus 1 multiplied by 0. That means the correct answer is 0, which is option A. Okay. So let's move towards the next sum. Question number 27. What is the remainder when a to the power 4 plus 1 is divided by a minus 2? Okay, before I start with the solution, I want to make you remember about the remainder theorem. That is very important. What does it states? The remainder theorem. Please do remember the remainder theorem. That is, say f of x is a polynomial. Okay, and if I divide f of x by x minus alpha, say it will not be completely divisible. Say we will get the remainder r. Say then we can derive the result of r as f of alpha. So the r will be equals to f of alpha. That what it means. If r is the remainder, then we can say that r equals to f of alpha. That what does remainder theorem means. Okay, so we are going to use this concept on this particular sum. Let's see how we can use it. Look here, let h of a equals to a to the power 4 plus 1. I have named this polynomial as h of a. Okay, so therefore since we are asked to find the remainder when it is divisible by a minus 2. Okay, so here a minus 2 need to be compared with x minus alpha. So we got, after comparing this with x minus alpha, we got alpha, the value of alpha is 2. So according to the remainder theorem, according to the remainder theorem, we can get the result, we can get the value of remainder as h of 2. That means 2 to the power 4 plus 1. So 16 plus 1, 17 is the correct answer. Let's check here. Option A is the correct one. Okay. Now let's move towards the next sum. Question number 28. That is, if x plus 1 by x equals to 6, then x to the power 4 plus 1 by x to the power 4 is, okay, start with x plus 1 by x equals to 6. Both side, let's do square the both side. Okay, squaring the both sides, we get x plus 1 by x whole square, 36, correct? Now we can write, let's expand this according to the identity, x square plus 1 by x square plus 2 equals to 36. That means x square plus 1 by x square, it becomes 34, correct? Now again we will square the both sides. So squaring the both sides, we get x to x square plus 1 by x square whole square equals to 34 whole square. Now x to the power 4 plus 1 by x to the power 4 plus 2, and after squaring the 34, we'll get to see it as 1156. Okay. Now look here, x to the power 4 plus 1 by x to the power 4 as 1156 minus 2, that becomes 1154. So 1154 is the correct answer. Let's check it here. Yes, option B is the correct one. Now let's move towards the next sum. Now solve question number 29. If a cube b equals to abc equals to 180, then a, b, c are positive integers, then find the value of c. Okay, so let's write the given information first here. Now, separately, I can write a cube b equals to 180 and abc equals to 180, correct? Now, from the first relation, I can write b in terms of a, 180 by a cube. Same here, I also write b, 180 by ac. Now, both the results refer the value of b, right? That this means they are equal. So let's make them equal, 180 by AC. So here C A square is C. So we can write A as root under C, right? Now substituting this value in the equation, in this particular equation, let's name it 1. We can write here root C multiplied by B multiplied by C equals to 180, right? Now root c means c to the power half multiplied by c, 180, right? Now here you need to remember the exponent formulas, right? When the base are equal and we what we can do, the relationship, the operator is multiplication, they are multiplied in relationship but the base are equal, we can write the exponents in terms of the addition, means a to the power m plus n. Okay, so here base are equal, c, both are c, so we can write half plus 1 equals to 180, or b multiplied by c to the power 3 by 2, 180. Now they have already said that a, b, c are positive integers, correct? So by heat and trial, we can see that the value of C should be 1 and the value of B will be 180. Okay, so here option B is the correct answer. Okay, next question number 30. So you can see that if P plus Q equals to 10 and PQ equals to 5, then the numerical value of P by Q plus Q by P will be, let's start with the solution. Okay, so we are given with the value of P plus Q, that is 10, and also PQ, that is 5, right? Now let me write one expression, that is P plus Q equals to 10. Okay, what can I do? I can square both the sides. Okay, squaring both the sides, I will get P square plus Q square plus 2PQ equals to 100, correct? Now P square plus Q square, I already know the value of PQ. Let's put here 100. So P square plus Q square equals to 100 minus 10. That will give us the value 90. Now what can I do? Look, let's take the expression that we are required to find the answer, P by Q plus Q by P, right? So P by Q plus Q by P. Let's do the LCM. Will become P square plus Q square, correct? Now we have just got the value of P square plus Q square, that is 90, and already the value of PQ were given, so 5, that means the answer is 18. So here option D is the correct one. Okay, okay students, now we have question number 31. When x plus y plus z plus 3 multiplied by x to the power 1/3 y to the power 2/3 plus 3x to the power 2/3 y to the power 1/3 is divided by x to the power 1/3 plus y to the power 1/3 plus z to the power 1/3, what is the remainder? Okay, so let's start with the solution. First, I will start with this expression that has been given in the question. So here, let me write it first. X plus y plus z plus 3 x to the power 1/3 y to the power 2/3 plus 3 x to the power 2/3 y to the power 1/3. Okay, now I can balance it in such a way so that this x can be written as x to the power 1/3 whole cube plus y to the power 1/3 whole cube plus 3 x to the power 1/3 multiplied by y to the power 1/3 whole square plus 3 x to the power 1/3 whole square multiplied by y to the power 1/3, and this z can also be written as z to the power 1/3 whole to the power cube. Okay, now look here, look at the first 4 terms. Okay, so this is the form of a plus b whole cube. First, let me make you remember of that identity itself. A plus b whole cube gives us the result a cube plus 3a square b plus 3ab square plus b cube, right? So here we can compare, we can assume x to the power 1/3 as a and y to the power 1/3 as b. So comparing with this identity, we can write it as this way: x to the power 1/3 plus y to the power 1/3 whole cube, right? And also z to the power 1/3 whole cube, correct? Now this becomes, if I assume it as p and this is q, this becomes p cube by q cube, right? Means a cube plus b cube. So again, we have to remember the result of that identity, p cube plus q cube. That will be p plus q multiplied by p square minus pq plus q square, correct? So I will expand this in form of xyz with the help of this identity. That will be x to the power 1/3 plus y to the power 1/3 plus z to the power 1/3. Also x to the power 1/3 plus y to the power 1/3 whole square minus x to the power 1/3 plus y to the power 1/3 multiplied by z to the power 1/3 plus z to the power 1/3 whole square, correct? Now look here, this expression is a factor of this expression of the first polynomial, of the first expression, right? So since this is a factor, so whenever we are going to divide this with the help of this factor, we will always get remainder as 0. So here remainder is 0. Option C is the correct one. Okay, now let's move towards the next question. Now let me solve question number 32. The value of lambda for which the expression x cube plus x square minus 5x plus lambda will be divisible by x minus 2 is. Okay, so first let's write the given expression minus 5x plus lambda, correct? So here we again need to use the factor theorem. Okay, and what does it states? The factor theorem, that is, if f of x is a polynomial and this polynomial is divided by with the factor x minus alpha, if x minus alpha is a factor of it, means if we divide, now we will get the remainder as 0, then we can say that f of alpha give us the value 0. Okay, so since factor of this expression, factor of this expression is x minus 2. It's already mentioned that. So we can compare x minus 2 with x minus alpha. We will get to see that alpha equals to 2 here. Means if we name it as, say, f of x, so if we put f of 2, we will get the value 0. So let's check it. 2 whole cube 2 whole square minus 5 multiplied by 2 plus lambda equals to 2. With help of this equation, we are going to find the value of lambda, that is minus 8 minus 4 plus 10. So here minus 2 is the value of the lambda. That means option B is the correct answer. Okay. Let's start solving question number 33. If P by f minus g, f plus g minus 2e equals to q by g minus e, g plus e minus 2f equals to r by e minus f, e plus f minus 2g, what is the value of p plus q plus r? Okay, so here we are given with 3 ratios and those are equal in value, correct? So first, let me tell you that if some ratios are equal, let's say A by B, C by D, and E by F, these 3 ratios are equal. So we can assume them, they are equal to, say, a value K, where K is the ratio constant. Okay. Ratio constant. That means from here, we can separately write all the ratios equals to K. Correct. These are things we get from the concept of ratio proportions. And here we can write A in terms of B, C in terms of D, and E in terms of F. So the same concept we are going to use in this sum to solve it. So let's say these three ratios are equal to K, where K is the ratio constant, correct? That means I can write P by F minus G by F plus G minus 2E plus G minus 2E equals to K. So we can write P in terms of this value F minus G, F plus G minus 2E. Okay, let's name it equation number 1. Next, Q by G minus E, also G plus E minus 2F. G plus E minus 2F. That means we can write equals to K. So we can write G equals to K multiplied of this value. Okay, let's name it equation 2. Now the third ratio is R by E minus F and E plus F minus 2G. That means we can write R equals to K multiplied by minus 2G. Let's name it equation 3, correct? Now with if we are going to find the value of P plus Q plus R, so from these three equations we can write they are equals to, let's take K common from all these three terms, and it becomes okay, so here F plus G minus 2E plus G minus C, G plus C minus 2F plus E minus F, E plus F minus 2G, correct? Now let's drop the brackets and expand them. So it becomes F square, F G minus 2EF minus GF, G square 2EG plus G square plus GE minus 2FG minus GE minus E square plus 2FE plus E square plus EF minus 2GE minus CF minus F square 2GF, correct? So we can see all the terms are going to cancel out. How? If G plus FG minus FG minus 2EF plus 2EF minus G square plus G square. EG also this thing GE, GE. Yes, so K multiplied by 0 means 0. That means the value of P plus Q plus R is going to equal to 0, which is option C is the correct one. Okay. Here, question number 34. If L, M, and N are unequal natural numbers such that L square equals to Mn, consider the following. Okay, so here we are given three statements on the basis of this given equation that L, M, N all are unequal natural numbers, correct? That means we can write L not equals to M not equals to N, correct? And also we are given L square equals to Mn. Now let's check one by one. L plus N by N equals to M plus L by L. Okay, let's start with the first statement. L plus N by N equals to M plus L by L. So let's do the cross multiplication. Means L square, both will got cancel, equals to Mn. Okay, here we are getting the same result. Let's check the second statement, that is L by N minus L equals to M by L minus M. Okay, so do the cross multiplication first. Again, we are getting result L square Mn. Okay, again. So let's check with the third statement, that is L plus N by N minus L equals to M plus L by L minus M. Okay, so here if we do the cross multiplication, we will get L square minus ML plus NL minus Mn equals to Mn plus NL minus Lm minus L square, correct? So here we are getting L square equals to 2mn. That means again L square equals to mn. So every time we are getting the given information, that means all these three statements are correct. So here option D is the correct one. Okay. Now let's move towards the next sum. Question number 35. Which of the following is the correct expansion of x plus y plus z whole square? Okay, let me show you the step-by-step method of this expansion. Here, first we can treat any two of terms, the sum of any two of terms as a, and the third one is b. So, okay, I will treat it as a plus b whole square plus 2zx plus y. Correct. Next, 2xz plus 2zy. So you can see that x square plus y square plus z square plus 2xy 2yz plus 2zx means option C is the correct answer. Okay, so let's move towards the next sum. Question number 36. If P plus Q plus R equals to 0 and P, Q, R not equals to 0, then what is the value of, there is an expression given. First, start with whatever we are given in the question. P plus Q plus R equals to 0. Okay, so in the next line, we can bring this r in the opposite side. It becomes minus r. Now do the now square both sides. So here p square plus q square plus 2pq equals to r square. Now I can write it this way. Okay, now look at here, p square plus q square minus r square. It's given in the denominator of the first term. Right. So this way we are going to find the value of the denominators of other two terms as well. And for that, how can I do that? Okay, so let's name it equation 1. Then again, in the next time, I am taking, say, q to the other side. So here, same, square the both sides as well. Okay, let me write here, yes, minus 2PR. Yes, so we got the value for the here, yes, for the third denominator for the third expression, p square plus r square minus q square equals to minus 2PR, correct? So here, next, now this time we are taking p to the opposite side. Let's name it 2. So it becomes q square plus r square minus p square equals to 2QR, right? Name it question number 3. Now let's write the expression that is given here. 1 by p square plus q square minus r square, 1 by p square plus r square minus q square, 1 by q square plus r square minus p square. Okay, now from 1 to 3 we are going to put all the values. That is, for p square plus q square minus r square, the value is minus 2pq. Okay, next p square plus r square minus 2pr. And for the third, again, I missed minus here. So minus 2QR it should be. So minus of 2QR, correct? Let's take all the minus. Common and do the LCM. So it becomes R plus Q plus P, right? Now, do remember what is the value for P plus Q plus R? That is 0, already given. So 0 by 2PQR. Since P plus Q plus R equals to 0, correct? So it will give us the final answer 0 as well. So here option A is the correct one. Okay. Let's move towards the next sum. Here is question number 37. If the roots of the equation p square plus p plus 1 equals to 0 are lambda and delta, then lambda plus delta equals to minus 1 and lambda, the product of lambda delta equals to 1. Okay. Also, the roots of the equation p square plus dp plus e equals to 0 are delta plus lambda and lambda by delta. Sorry, it is delta by lambda and lambda by delta. What is the value for D? What is the value of D? Here, that is the question. So here we are going to start question number 37. If the roots of the equation p square plus p plus 1 equals to 0 are delta and lambda, then delta plus lambda equals to minus 1 and the product of delta and lambda equals to 1. Also, the roots of the equation P square plus dp plus E equals to 0 are delta by lambda and lambda by delta. What is the value of D? Okay, so here it is mentioned that for the equation p square plus p plus 1 equals to 0, the two roots are delta and lambda. So from the relationship between the roots and the coefficients, we can write the sum is equal to -1 and the product is equal to 1, correct? And also there is another quadratic equation given. Those roots are okay. Now we need to find the value for the value of the D. So to do so, let's start with, say, from the relationship between roots and the coefficients, we can write for this quadratic equation, we can write the sum equals to minus D, correct? Also, so here, let's do the LCM. Now let's find the value for delta square and lambda square. That will be, if I treat it as a square plus b square, so from the identity I can write, let's put the values from the first quadratic equation, that is -1, correct? So here -1 by 1 equals to minus D. That means the value for D is 1. So here option A is the correct answer. Okay. Now let's move towards the next sum. Question number 38. If x cube plus y cube equals to 35 and x plus y equals to 5, then the value of 1 by x plus 1 by y will be. Okay. So let's copy down whatever informations we are given here. X plus y equals to 5, right? Now look, we have an very important identity, that is right. So from A here, I can write, let's put all the values. Sorry, it should be 90. So yes, the value of xy is 6, correct? Now let's find the value for the another expression, that is 1 by x plus 1 by y. Let's do the LCM. 5 by 6. So yes, the required answer is 5 by 6. Option B is the correct one. Okay. Now let's move towards the next sum. If question number 39, if x equals to 4ab by a plus b, then the value of, okay. So how can we proceed with this sum? Look here. It is a very interesting question, I must say. X equals to, and important as well. So what can I do? Look, this 4ab can be break as 2a 2b this way. Okay, so first, and let me bring down 1 to the below of x, so it becomes x by 2a. Now let's do componendo and dividendo. So here what I have done, componendo, dividendo. Okay. So I got the value for x plus 2a by x minus 2a, and that is also 3b plus a and b minus a. Now look here, already I got the value for the first term of this expression. Now how can I get the value for the second term as well? So let's look here. Again, let's name it equation number 1. Again, let me write this line first. Okay, now I'm going to bring down 2b. Okay, so again, let's do the componendo and dividendo. It becomes 3a plus b, a minus b, right? Let's name it 2. Now, from 1 and 2, we get, if we add 1 and 2, we get x plus 2a by x minus 2a plus x plus 2b by x minus 2b, and that is also 3b plus a minus b minus a by b minus a, and 3a plus b by a minus b. So 3b plus a by b minus a. I can make the denominator same by taking common minus 1 from a minus b, and that will make this plus also minus. Okay, so let's do the LCM. Yes, so here 2b minus 2a. So 2 is the correct answer. Now, which option? Option D is the correct one here. Okay. Next, we have another question. And the last question from this test paper, that is question number 40. If x equals to √3 plus √2, then the value of x cube minus 1 by x cube. Okay. So let me first write the value for x. And with help of this, I'm going to find the value for 1 by x. Since √3 plus √2 is the irrational number, what will we do in the next step? We will rationalize it by multiplying both the numerator and the denominator with the conjugate. That is √3 minus √2. Okay, so it's in the form of a plus b and a minus b, product of. That means it can be written as a square minus b square, correct? So yes, √3 minus √2 by 1 means √3 minus √2. So you got the value for 1 by x and x as well. Now, x cube minus 1 by x cube, right? So let me use the formula for a cube minus b cube. That formula is a minus b multiplied by x square plus a into b plus 1 by x square, correct? We already know the value for, okay, so here we have to put the value for x and 1 by x as well. And in a bracket, we are having x square plus 1 by x square plus 1, correct? Now, 2 root 2, okay? So, look here, it's in the form of e square plus b square, correct? Again, we can use one identity. One of the identities, that is x plus 1 by x whole square minus let me write here the value root 3 plus root 2 plus root 3 minus root 2 whole square, also minus 2 plus 1. So 2 root 3 whole square minus 1. Next step, 4 multiplied by 3 minus 1, that is 12 minus 1, 2 root 2 multiplied by 11, that is 22 root 2 is the answer. Okay. Here option C is the correct one. Okay, students.